35. We got two targets for today. One, to be able to graph a linear and quadratic function using our graphic calculator. Remember that old one, the linear one, the one we did at the beginning of the year, like nonstop? We're going to combine that with a quadratic. Call this a system of equations. Yeah, we talked about that too. So we have two graphs on one coordinate plane. So we're going to put a couple things together today. So we got a couple of equations. We're using the fancy names, the f of x, the g of x, but remember that this is, just giving you a name and the input, a name and an input for what this is. We're going to start with a little review of graphing a linear function. So remember that this is the slope, and the slope can always be put over 1, where the 3 is the y-intercept. Let me get a fun color. Yeah, let's do something other than that. So we're going to graph this with the y-intercept first, up 3, 1, 2, 3, boom. I did that because of this 3 right here. And then it's going to move -2 over 1. So it's going to rise -2 and then move to the right 1. So that's actually down 2 and right 1, down 2, right 1, down 2, right 1. You also could have gone up 2, left 1, as long as you make one negative move. So remember, linear is a line, and those are the points that make a line. So we will connect them, we will extend them, and we will give it a name, which is g of x equaling -2x plus 3. There you have it. We just graphed the first function, the quadratic. Quadratic. Now what makes this a quadratic? X to the second power, all right? And remember that these make a U shape, and we can put down the y-intercept, okay? We can put down the 3, just like we did for the linear, and that's going to be the same point. But unless you're a super genius, you're going to need a calculator for the rest of this. So we move to the calculator, and I'm going to always start with the graphing calculator because this is what is allowed on the reading exam. Cell phones and computers and Desmos.com are not, sadly enough. So we go to y equals, and you enter the equation that you see, 2 variable button for x, and then you got to square it. And then we want to go -8 x, and then plus 3. So there you have it. Whoops, large screen so you can see. So now that that is entered, go ahead and press second table. Because, you can look at it, but we're not eyeballing it here. And just like we talked about last class, you got to find that U shape where numbers are going to be the same in the Y column. So we go down, and ooh, here we go. I think we're getting into it. Please don't keep going. Let me go down again. All right, so there we go. So there we go. We got some values that we can actually put on a graph. We can see the 13 on the top with the 13 on the bottom, the 3 with the 3, the -3 and the -3, and the 2 and the -5. And I'll ask the class here, the most important part is the turning point. Who thinks I can pick that one out? The turning point. 4, 3. Nope, it would, because 3 has a match with that one. In our little table here, and we want to start at negative, let's start at, -1, I guess. -1, 0, 1, 2, 3, 4. Is that right into the C there? Is that what that is? C, 4, and then maybe 1 more 5. Hopefully you can see those. Yes. -1, 0, 1, 2, 3, 4, and 5. Now, let's put down the values that we saw in the calculator, and they went 13, 3, -3, -5, and then they repeated itself. So, negative, I'm going to show you this one again. -5 was there, and -3, and then it was, in my memory so bad, +3, -13, and because 2, -5 was your turning point, they're just going to repeat on the other side. So -3, +3, and 13. I'm not sure why I made that negative. +13. Boom. All right. So let's plot them. Let's put them down on paper for this nice little quick touch screen. Can't do anything with -113. Let's go 0 up 3, got that. 1 down 3, 1, 2, 3. And 2 down 5. And once you reach your turning point, you know it's going to go in the other direction. And it's going to have the same height. So 3 and negative 3. And then 4. 1, 2, 3, 4. And 1, 2, 3. So there you have it. We're going to whoop, whoop, make that U shape. And that's always a good idea to label it with the equation f of x, or 2x squared minus 8x plus 3. So we did graph some quadratics last class. I didn't get to see these guys in class, so hopefully when you saw it in class it made sense. If you have any questions, let me know. And now that these guys are here, hopefully that's helping them see it in person. So today's class, though, is all about trying to find where they're equal. And this comes up a ton in the Regents, and so that's what this statement is. When are these going to be the same? Well, they're the same. They're the same right here when they intersect. So that's when they share this point and they share this point. So the 2 points that they intersect at are 0 up, right? So 0, 3. That's this guy right here. And this one that was 1, 2, 3, 1, 2, 3. Positive 3, 3 right, negative 3, 3 to the left. So those 2 points were important to us. Now in terms of the answer to the question, you can't write down the points. You want to know the x values. So the x value for this point was 0. The x value for this point was 3. So x equals 0 and x equals 3 would be our 2 answers. I'll take a question. If you have your calculator and you type in more than one equation, so let's say you have the quadratic, and then we also have a linear one, which was negative. We'll use that button below the 3, 2x, and then plus 3. And then we go to the table, second graph. We're going to see something. I wish I could write on this. Actually, I can, but you're not going to be able to see it at home. So you're going to see some common y values. So 0, 3, 3. And 3, negative 3, negative 3. So when you put it in the table and you see that these are the same, that's telling you that this x value and this x value answer the question. It's the point, it's the number that allows them to be equal or the same value. And in math, we find that important. Okay? So another way you could have done that. Oops. Put this way. We've got another quadratic. We've got another linear one. Can anybody pick out the quadratic from the linear? Excellent. Can anybody tell me why you do one from the other?
Because the quadratic has a x power.
Yes, because of the x to the second power. Perfect. We got a good understanding of what we're talking about here. So keep it simple, no fancy function notation, just y, and that's totally fine. So let's go to the calculator, and let's go to y equals, and let's clear out our space junk. All right, get rid of all this, and just go with x squared. So x to the second power minus 4 x minus 5. So I like to do it one at a time. I think it is kind of confusing if you do it more than once. So second and graph. And I'm looking for that turning point, and I don't have to move a muscle. Luckily, it is in the exact same spot. Now, your calculator might not be in the same spot, so you might have to move up and down. But I have identified the points I'm looking for. You can tell me the turning point. Yeah, that's 2, negative 9, where there's no other point that shares a 9, but there's negative 8, negative 8, negative 5, negative 5, 0, 0. So let's go ahead and put that down, and I'm going to put that in the middle here. 2 and negative 9. And then there was a negative 8 on this side, and a negative 8 on that side. And then there was negative 5 and 5. Negative 5 there. Negative 5 there. The blue on the blue is very bad. 0 and 0. So I apologize. let's just fill in the rest of these numbers here, shall we? We have 2 there, so that's going to be 3, 4, 5. These go right in order. 1, 0, and -1. Now, once we've got those, let's go ahead and plot them. I'm going to plot just the quadratic first, and the reason being, we're going to talk about some things that we talked about last class. So, first point, -1, 0. Remember, when it's right on the x-axis like that, that's a 0 value. That's important to us. 0, -5, 1, 2, 3, 4, 5. The y-intercept. Not a 0 value. Remember, this is given to you in the equation only. Y-intercept there. Oh, look at that. Same y-intercept. That's going to be important to us in a minute. We got 1, -8. 1, 5, 6, 7, 8. Then with the starting point at 9. And then we reverse course and go up in direction and another 0 value. So, go ahead, freehand this one, no rulers needed. U-shape, arrows on it to show that it goes on forever and ever, and then maybe the label whenever we're dealing with more than one graph on the same coordinate plane. So there you go. Starting with the y-intercept. So going down 5, so it's -5. 1, 2, 3, 4, 5. There we go. And we've got our first solution, our first answer here. That is going to be 0, -5, because that's the point where they meet. And now I'm going to rise 2 and run 1. Remember, you can put any number over 1. So up 2 over 1, 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 up 2. Ooh, that's another good one. Up 2 over 1, and there we go. So down 2 over 1 for the bench as well. So this is a good learning opportunity to see in the calculator what these answers are, because I freehanded this. After 0, I just kind of like drew it on my own. So I actually don't trust this point, because that's something that I did without actually plotting points. So that's why we go to the calculator, we go to y equals, and we type in the second equation. So 2x and minus 5. I go second, I go graph, and who would pick it out? So we pick out the other solution, because I see one right here. Is there a second one? Not yet, right? Not yet. But we know where it happens. We know it happens somewhere in the positive x direction. So maybe we can do a little searching. And we search, there it is. It's at 6 and 7. So because there's 7, 7. Let's see how good my freehand was. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh my God, I nailed it. How good was that? 6, 7, equaled out the points. So you have been able to find the two answers to this. And I'm just going to put them here. -5 here, and it would be 6, 7, 7. Yeah, terrible color on that sand, huh? 6, 7, 7. There's one. There's your second answer. And we just called it x equals 0,